Now we are starting with section A. In section A, the first question is based on MCQ. Now, the first part is a body is acted upon by two unequal forces in opposite directions, but not in the same line. So, the combined effect of the forces. As you can see, they have given us the four options over here. Now, body is free to move and it is being acted by two forces not having the same line of action. So our option here will be D. That is, the body will have a rotational as well as translational motion. Okay, now moving on to the second subpart. The two forces F1 and F2, the two forces you can see both of same magnitude but opposite in direction, and the moment of couple is given to you 9. Okay, so if I write the formula for moment of couple, so moment of couple you can write as force. You can select one of these forces multiplied by the couple arm. Now here the couple arm means distance between these two forces, so that will be the couple arm. Okay, here moment of couple is given to you as 9. Now we have to take magnitude of one of the force, so it's 15 into. Now here the couple arm here means the diameter. You can see couple arm means here diameter, so you can write here diameter. So diameter is equal to 9 by 15 meter. So we can convert it into centimeter now. 9 by 15 into 100, and we will get it converted into centimeter. So 3 3s are 3 5s are 5. So diameter is coming 60 centimeter. So we have got diameter as 60 centimeter. Now according to the question, we need the radius. So radius will be half of the diameter. So you can say that radius will be 30 centimeter. So here our option will be A part, 30 centimeter. Now moving on to the next one. What should be the angle between the force and displacement to get maximum work? You must be knowing, for maximum work, angle between them should be 0, because cos 0 will give you maximum value 1. So angle for maximum work, it should be 0 degree. Moving on to the next one. Name the quantity which is measured in watt hour. So of these four options, energy is measured in watt hour. Now the next we have, choose the correct relationship between kinetic energy and momentum. So we will be going for option D. So this will be the correct option for this part. Now moving on to the next part. A ball of mass 50 gram is thrown vertically upward with initial velocity. Now when you are throwing the ball vertically upward, that means you are providing kinetic energy. So let's calculate the kinetic energy provided to the ball. It's half mv square. So here m is 50 grams, so we can convert it into kilogram, and then v square, so square of 20. So if we simplify it, we are getting kinetic energy imparted 10 joule. So this is the kinetic energy imparted. Now we know by the law of conservation of energy, whatever the kinetic energy you will impart, when the body goes to the highest point, body will have the same potential energy. So kinetic energy is 10 joule. So when body goes to the highest point, it will be having the potential energy of 10 joule. So here we can go for the option C. potential energy at the highest point will be 10 joule. Okay, next see the lever for which mechanical advantage is more than one. So here we are talking about a lever which is having mechanical advantage more than one. So a lever which is having mechanical advantage more than one. So here we can say it will be class 2 lever, and in class 2 lever we have load between effort and fulcrum. So we will go for option B. Okay, the next one. State the kind of lever which always has mechanical advantage less than 1. So for this we will go in class 3 lever. It has mechanical advantage always less than 1. Next one, the velocity ratio of an ideal single movable pulley. For a single movable pulley, remember velocity ratio is 2. So we will go for the option A. Now the next one, an object in a denser medium when viewed from a rarer medium appears to be raised. Now object appears to be raised means there is a shift. So the shift is minimum for, so it will be minimum for red light. Okay, now next we have now here in the diagram they have shown you a ray striking the surface at an angle of 42 degree. And now we have to find the path. Now as the ray is striking the surface at 42 degree, so first of all what you will do, you will draw a normal here, and by drawing the normal you will try to calculate this angle which is called the angle of incidence. So from 90 if you subtract 42 you will get angle of incidence is equal to 48. Now here you can see the ray is traveling from glass to air, means it is traveling from denser to rarer, and angle of incidence 48 is exceeding the critical angle. So both the conditions for total internal reflection are being satisfied at this point. Rays traveling from glass to air means denser to rarer, and the angle of incidence is exceeding the critical angle. So as both the conditions for total internal reflection are being satisfied, so we can say the ray will suffer total internal reflection. So here in this option we will say the ray will suffer total internal reflection. Now moving for the 12th part. The energy of an electron is given to you and you have to express it in electron volt. Okay, now how we will convert it? Remember 1 electron volt is equal to 1.6 into 10 raised to power of minus 19 joule. Now when you have to convert this much of joule into electron volt, what you will do, you will divide 4 into 10 raised to power of minus 19, you will divide it by 1.6 into 10 raised to power of minus 19. So on dividing it, this will cancel out. 4 divided by 1.6 will give us 2.5. So that means we will go for option D, 2.5 electron volt. Okay, moving on to the next part. A concave lens forms the image of an object. Now as you can see, it is a concave lens. So remember, concave lens gives always a virtual image. Virtual image is always upright and it always gives a diminished image. So virtual, upright and diminished. We will go for option D. Now moving on to the next part. For a convex lens, an object is kept between f1 and 2f1, the characteristics of the image formed will be. Now object is between f1 and 2f1, so that means we will get a real, magnified and inverted image. So we will go for option C. And then now the last MCQ, where must an object be placed in front of a convex lens so that the image formed is upright and enlarged? Now see, it's a convex lens which is giving upright and enlarged image. There is only one condition when convex lens gives an upright image, and that is when object is between optical center and focus. So you will go for option C. So these were the MCQ questions. Now moving on to question number 2. Okay, now we will solve these questions Now see, the first question is, you have to differentiate between uniform circular motion and uniform linear motion in terms of velocity and acceleration. Okay, so let's see what will be our option. We have to differentiate between, so we have to differentiate between, see, uniform circular motion and uniform linear motion. Now first of all, differentiation is to be done in terms of velocity. Now remember, in the first part, differentiation is to be done for linear velocity. Okay, so in answer 2 and the A part, first we are doing differentiation in terms of variable, in terms of velocity. Now remember, for uniform circular motion, velocity will be variable velocity, and in case of uniform, right, the next one is uniform linear motion. So for uniform linear motion, remember, velocity is constant. So the first difference was to be done in terms of okay. Now in the second part, we have to do the differentiation in terms of acceleration. Remember, UCM, that is uniform circular motion, it is an accelerated motion. It is an accelerated motion. Whereas uniform linear motion, it is unaccelerated motion. So in the first part, we have to differentiate between UCM and ULM. First in terms of velocity, then in terms of acceleration. Okay, moving to the part B of this question. Now the part B says, see, a boy of mass m climbs up stairs of vertical height h. What is the work done by the boy against the force of gravity? Now see, work done by the boy. Now as we can see in the first part, boy is moving in the upward direction, right? His displacement is in the upward direction, and to move in the upward direction, he is applying the force in the upward direction. So as force and displacement both are in the same direction, so work done will be positive. See, body is moving. Here they say the boy is moving in the upward direction. So displacement is in the upward direction. Now the force he is applying, that is also in the upward direction. So both are in the upward direction. So his work done will be positive. So we will say work done by the boy will be equal to positive mgh. Now see in the second part. Now in the second part they say you have to calculate work done by the force of gravity. See, displacement of boy is in the upward direction, but force of gravity is in the downward direction. So force and displacement both are in opposite direction. See, boy is moving in the upward direction, so displacement is in the upward direction, but the force of gravity acting on the boy, it is in the downward direction. So force and displacement both are in opposite direction. So work done will be minus mgh. This way we can calculate work done by the force of gravity. Now moving on to the C part. In the C part they are saying state the energy changes in the following cases. First of all, they are using microphone. Now when you are using microphone, then remember energy conversion will be from sound energy to electrical energy. Sound energy to electrical energy. Okay, the second part is we have to find the energy conversion in photoelectric. It is in photoelectric cell. In photoelectric cell, remember light energy is converted to electrical energy. So this will be the solution for C part. Now moving on to the D part. Now the D part they say state the condition when on applying a force the body has translational motion and the body has here see state the condition when applying force the body has translational motion and rotational motion. So the first part we have to write the condition for translational motion. Now translational motion is possible only if when body is free to move. Body is free to move. And for rotational motion it is possible only when body is pivoted at a point. Body is pivoted at a point. This is clear to you? Okay, now see the E part. E part says how does centripetal force differ from centrifugal force with reference in the direction in which they act. So here we have to compare centripetal force and centrifugal force in terms of direction. Okay, so in E part, first of all we have to compare these two forces in terms of direction. So centripetal force acts towards the center of circular path. centripetal force always acts along the radius towards the center of the circular path, whereas the centrifugal force acts outwards along the radius away from the center. Of circular path. So this is how you can differentiate between centripetal and centrifugal force in terms of their direction. Second part, they say you have to compare their magnitude. Now remember, the magnitude is same, so you can write the comparison as 1:1. Okay, now moving to the F part. Now see, in F part they say a block and tackle system has a velocity ratio 4. Okay, so velocity ratio is given to us as 4. A man can exert a pull of 500 kgf. Okay, what is the maximum load he can raise with this pulley system if its efficiency is 75%? Now in this question, efficiency is given to us as 75%. Now first of all, we will write the formula for efficiency. It is MA upon VR into 100 for percentage. Efficiency, as you can see, is given in the question. It is given 75%. 75. MA not known to us, upon velocity ratio. Velocity ratio is given to us as 4 into 100. Now when you cross multiply and you simplify it, so let's see what will be the result. 75 into 4 upon 100. 75 into 4 will give you 300. 300 upon 100. So mechanical advantage is 3. So as the efficiency was given, VR was given, so we have calculated mechanical advantage. Okay, now moving on to the next one. Now they have asked us to calculate the maximum load. Now we have to calculate the load. First we have calculated mechanical advantage. Now mechanical advantage is equal to load upon effort. Mechanical advantage we have calculated as 3. Load, as you can see in the question, load we have to calculate, and the effort given to us. See, they have given us the effort, that is the exert a pull of 500 kgf, that is the effort of the man, 500. So load will be equal to 500 into 3, that is 1500 kgf. So we have calculated load. Now the next part, they say if the effort end moves a distance of 90. So here they have given you distance moved by the effort. This is DE. Distance moved by the effort is given 90. What distance does the load move? And they have asked us to calculate the distance moved by the load. This is to be calculated. Now remember, displacement of effort and displacement of the load point, it can be compared with the help of velocity ratio. So we will use the formula for velocity ratio. It is dE by dl. Velocity ratio is given in the question as 4. Displacement of the effort is given to us as 90, and they are asking us to calculate the displacement of load. So displacement of load will be equal to 90 upon 4. So this will give you 22.5 centimeter. So this will be displacement of load. This is clear to you? Okay, now let's see the third question in part. We are doing section A, so let's move to the third question, that is the last question of section A. So we are doing the solution for question number 3. Okay, now let's see what's the question. Question number 3. Now question number 3 given to us. See, a monochromatic ray of light passes from air to glass. The wavelength of light is in air, it is given lambda. The speed of light in air is c. Now this is the wavelength of light in air, and this is the speed of light in air, and this is the speed of light in water, v. The refractive index of water is given 4/3, and now we have to write the relation connecting between c and v, and also the relation between the wavelength of light. Okay, see, first of all we have to write a relation which is connecting v and c. See, now let us see what was given in the question. If you just go through the question one again, so you can see they have given you wavelength of light in air. So wavelength, let it be represented by lambda. So wavelength in air is given to us. Lambda is the wavelength in air. So I can write it like this: wavelength in air, it is given to us as lambda, right? What else? Speed of light, they have given us speed in air, it is given as c. What else they have given? They have given us the speed of light in water as v. These three informations are given to us, and along with it they have given you a refractive index of water is given with respect to air, 4/3. So this is the information given in the question, right? Okay. Now first of all I will write the formula for refractive index in terms of speed. Now see, formula is like this. This is the formula for refractive index of medium 2 with respect to medium 1, and the formula is speed of light in medium 1 upon speed of light in medium 2. So let us follow this formula. Now here you can see medium 1 is air and the medium 2 is water. So we will follow this formula. So we can write it like this. So on the right side I have to write speed of light in medium 1, and you can see here medium 1 is air. So I need to write speed of light in air upon speed of light in medium 2. Here you can see medium 2 is water. So speed of light in water. Now let's substitute. Given refractive index of water is given to you as 4/3. Okay. Speed of light in air, if you see speed of light in air is given as c. Speed of light in water is given as v. So if we do the cross multiplication here, you will get the relation 4v is equal to 3c. So in the first part they have asked you to write the relationship between c and v. So we have got relation between c and v. Okay, now I'm using the second formula for refractive index. Okay. So second formula for refractive index, again refractive index of second medium with respect to first in terms of wavelength. Refractive index of medium 2 with respect to 1 in terms of wavelength. So it is wavelength in medium 1 upon wavelength in medium 2. So we can write it in statement: wavelength in medium 1 upon wavelength in medium 2. Okay, now we will follow this formula. So we have refractive index of water with respect to air. Now here first medium is air, so we need to write wavelength in air. So wavelength in air upon wavelength in medium 2. Medium 2 is water. So wavelength in water. So let's substitute here. Refractive index is given as 4/3. Wavelength in air, if you go through the question, you can see wavelength in air is given as lambda. And we need to find wavelength in water. So let wavelength in water be lambda dash. Wavelength in water, हमने इसको suppose कर लिया lambda dash. Now the question says you have to find wavelength in water. So if I cross multiply, so wavelength in water will be equal to 3 times the wavelength in air upon 4. This will be your answer. Hope the first part is clear to you. Okay, now let's move on to the next part. That is part B. See, part B is like this. This says, state the conditions necessary for total internal reflection to occur. Now there are two conditions for total internal reflection to occur. So the first condition is ray of light must be traveling from denser towards rarer medium. That is the first condition. The second condition is angle of incidence must exceed the critical angle for the given pair of media. So these are the two conditions which must be fulfilled for total internal reflection to take place. This is clear to you? Okay, now C part. State the condition for each of the following. The first one is you have to write the condition for a lens to have both its focal length equal. Both the focal length must be equal. And the second is a ray passes undeviated through the lens. So first we will write the condition for a lens to have both its focal length equal. So a lens can have both its focal length equal if medium on both sides of the lens is same. If the medium is same, then the lens will have same focal length on both the side. Now the next we have to write the condition for a ray to pass undeviated through the lens. So that is the incident ray passes through optical center. If the incident ray will pass through the optical center, then the ray will pass undeviated through the lens. Okay, now moving on to the D part. So let's see what we have in the D part. In the D part, they say draw a ray diagram to show how a converging lens is used as a magnifying glass. Now, if we have to use a converging lens as a magnifying glass, then now they are saying converging lens. So converging lens means lens should be convex. So we will draw a convex lens. Okay, so let this be the principal axis. Let this be the focus. Focus on both sides will be same. This is f1. This is twice of f1. This is f2. This is twice of f2. Now to get the required image, we will keep the object here. We will keep the object between the optical center and the focus. And now see what type of image we will get. We will first of all take a ray which is going parallel to the principal axis. That ray, after refraction, will pass through the focus. So this is the first ray we have taken. Now we will take one more ray, and the second ray is passing through the optical center. So the ray that passes through optical center, it goes undeviated. The second ray goes undeviated. Now if I produce these two rays backward, because these are the diverging rays, so they will never meet each other on being produced forward. So we will produce them backward. Now if I produce them backward, then you can see the two rays intersect at this point, and so you will get the image here. So you can see you are getting a virtual image which is erect and magnified. So in this way we can say that we are producing a magnified image which is virtual and erect. So this is how you can use a convex lens as a magnifying glass. So at the last we can complete this diagram to show it as a convex lens, right? So this will be the diagram. Hope this is clear to you. Now moving on to the next question. The next part is E part. Now see what they say in the E part. The E part of the question says a postage stamp is kept below a rectangular glass slab of refractive index 1.5. When viewed vertically above, it appears to be raised by 8 millimeter. Now here the postage stamp appears to be raised. Postage stamp appears to be raised. So you can say this is the shift of the postage stamp. This is the shift for the image. So here shift is known to us. So shift is given, and the shift given to us is 8 millimeter. Then what else? Calculate the thickness of the glass block. Now if I try to explain you with the help of diagrams, it will be more easy for you to understand. See, this is a glass block, right? Now we don't know the thickness of the glass block, and the question says that we have to find the thickness of the glass block. So let the thickness of the glass block be x. Thickness of block, let it be x. Okay, so this is the thickness of the glass block, this. this is X. Now the postage stamp is kept over here. Now when it is viewed from above, the postage stamp, this stamp S, it appears to be at this point, S dash, that is the image. So postage stamp appears to be raised. So this portion will be known as shift, and it is 8 millimeter. Now if you see this diagram, then this width of the glass block, that is the thickness of the glass block, this is called real depth for the stamp. This is called real depth. So thickness of the block is X, and this thickness of the block will be known as real depth. So here you know the real depth is X. So the real depth is X. Now the postage stamp appears to be at this point. So this will be known as the apparent depth. This will be known as the apparent depth. Actually it is at this point, but because of the refraction it appears to be at this point. So this will be known as the apparent depth. Now how we will get the apparent depth? See, in the diagram real depth is known. We have taken the real depth as X. Shift is 8. So can we get the apparent depth? Yes, we can get the apparent depth. So the apparent depth, it will be, if from the real depth, if I subtract this shift, from the real depth, if I subtract the shift, then I will get apparent depth. Now in the question, a refractive index of glass is given to us. A refractive index of glass is given as 1.5. They have given us a refractive index of glass as 1.5. Okay, so let us use the formula for refractive index. The refractive index of glass formula is real depth upon apparent depth. So here the refractive index is given 1.5. Real depth we have considered as X, and the apparent depth is X minus 8. If I cross multiply, I am getting 1.5x minus 8 into 1.5 will give us 12 is equal to X. So this will be 1.5x minus X is equal to 12. So it's 0.5x is equal to 12. So now if I cross multiply and simplify, so it's 12 upon 0.5. So X is equal to 12 into 10 upon 5. So it's 24 millimeter. So the thickness of the glass block will be 24 millimeter, or you can also write it as 2.4 centimeter. This is clear to you now? Okay. Now moving on to the last part of this section. So let's see what we have in the last part. The last part says you have to consider a system of n pulley. Let X be the total weight of the lower block along with the load. In the balanced position, we have to show that mechanical advantage is less than the ideal value n. Okay, now let's start with this. First of all, they have said it is a system which is consisting of n pulley. Now remember, in block and tackle, whatever is the number of pulley given to you, same will be the velocity ratio. So here velocity ratio is equal to number of pulleys. So that is n. So we have got velocity ratio as n. Now remember, in n pulley system there will be one strand which will be supporting effort, and there will be n strands that will be supporting the load. Okay, here n pulley system, so there will be n strands supporting the load and one strand that will be supporting the effort. So here we can write effort is applied. See, whatever may be the number of pulleys, for effort we only get one strand. So effort is applied on one strand. Remember, number of pulley may be 4, 5, 6, 10, 100, whatever may be the number of pulley. But remember, effort can be applied only on one strand. So here we have effort is applied on one strand. So as effort is applied on one strand, so we can say effort is equal to tension in that strand. So we have got first equation. Now it's an n pulley system, so the load as well as the weight of the lower block. See, in the question they have given you load, right? They say let x be the total weight of the lower block along with the pulley in it. So x be the total weight of the lower blocks along with the pulley in it. So here we can write that the load, whatever the load is in the pulley, load and the lower block is balanced by n strands. So we can write load plus the lower block, they are being balanced by n strands, so it will be equal to nt, because in each strand tension will be T, so the total tension will be nt. So this we have got the second equation. See, now how can we get the mechanical advantage? Mechanical advantage is equal to load upon effort. Now from the second equation you can see load is equal to nt minus x. See here, to get the load you will transfer x this side, so load is equal to nt minus x. So in place of load you can write nt minus x upon effort. Now effort is equal to T. Effort is equal to T. Now this can be written as nt upon T minus x upon T, right? So T and T will cancel, so it is n minus x upon T. So you can see you are getting mechanical advantage which is less than n. You are getting mechanical advantage is equal to n minus x upon T. That means you are getting mechanical advantage which is less than n. So this was required. In the first part they have asked you to prove that mechanical advantage will be less than n. So here we have got mechanical advantage less than less than n. Now see, this was the first part, mechanical advantage to be shown less than the ideal value n. Now in the second part we have to show that efficiency is less than 1. Okay, let's see how we will calculate the efficiency and show it is less than 1. Now we know for efficiency formula is MA upon VR. Now see, we multiply by 100 only if we have to get efficiency in percentage. Here question does not say that you have to show it less than 100. You have to show it less than 1. So don't multiply by 100. So in place of MA you can write n minus x by T upon VR. Now you can see VR is equal to number of pulley n So if we break it, we can write efficiency is equal to n upon n minus x upon n t. N upon n will cancel out, so efficiency is coming 1 minus. So you can see you are getting efficiency less than 1. So this was required. So hope this section is clear to you all. In the next video, I will post you the solution for section B.